Okay, so the last day of class is Monday. Not this Monday, not today, but next Monday. So that means y'all have one more class, and that'll be the day that we do the last material. We're gonna have some material today. I've got to cover logs. The reason I've got to cover logs is because it's essential in calculus. So that's why I have to cover logarithms. But you've already had logarithms in your algebra classes in the past. So chances are, if you've had Algebra 1 and Algebra 2, this is just a review of that material. So the last day of class is Monday, December 4th. Notice I repeat Monday, December 4th about 6 times. Okay? Will there be somebody show up for class that day asking when's the last day of class? Yep.
Yes.
The last test will cover any material covered until December 4th. So if we cover 2 sections, then the last test will have 2 sections of work on it. That's it. Okay? This is something that I do every semester. I cover whatever I cover. I don't worry. I cover the important parts of the syllabus. All right? The last test, not the final exam, the last test, which will cover logarithms, will start on Monday, and it will end on the last day of finals. Okay? Just like all my tests and homework, they end at midnight. Homework will terminate at midnight on December 4th. Make sure you put a star beside that, so you won't be asking any DDA questions. Okay? After the last day of class, put a star beside this too. After the last day of class, which is Monday, December 4th, I will assign zeros for incomplete homework assignments. You may see your overall grade decrease if you haven't completed all the homework. I will be inputting in-class test grades, which will be used as bonus points. I'll be doing that like on that Tuesday, Wednesday, and Thursday. That's what I'll be doing for all my classes. I'll be in my office or at home working on that. Finals are from December 7th to December 5th to December 11th. You are responsible, you are only responsible as far as the final exam for what we cover in class. How do you know what we covered in class? You use your unit test to study with. Okay? If it's on that unit test, then it's probably going to be on the final, because that's the way I make my final. Now, will they be the same exact questions? No. Will they be similar questions? Yes. Anything not covered will be what?
Deleted from the grade calculation.
So that means homework. So that takes care of that question. Well, what about that right there takes care of that question. Anything we do not cover. So after Monday, anything that we don't cover, I'll delete from the curriculum or the grade calculation. I'll be doing that Monday, Tuesday, Wednesday, and Thursday. I'll be doing all that Tuesday, Wednesday, and Thursday. Your in-class final will be Monday, December 6th at 8 a.m. Write that down. I need as many as can be here so you can say you took an in-class final. And please, if you're absent, please don't tell anybody you didn't take the final. Please. Just say, yeah, he gave an in-class final. All right. In-class final will probably be 10 questions. If I'm lazy, it'll be 5 questions. All right. Online final, that's what you need to worry about, will be 30 to 40 questions, 2 attempts with a 2-hour limit. No bonus questions on this. This is all math, what you know. After you have completed all the homework, the unit test, and final, the last unit test, that's what that's supposed to say, last unit test and final, you should check your grade book for your overall grade. Now remember the bonus question. Do I give any bonus points at the end of the semester?
No.
No way, no how. Because I've given you all the bonus points with counting the highest grade at each unit test, giving you 10 bonus questions, which an idiot should not miss. Okay? and giving you those bonus in-class tests, those bonus points. So,
will the in-class final be bonus as well, or no?
yeah.
Okay, I was making sure.
I'm confused. It says Monday, December 6th. December 6th is Wednesday.
That's what it said in the thing. Okay, the what you call it, the academic calendar said Monday, unless I just read it wrong. I'm sorry, I could have read it wrong. Thank you for pointing that out.
You're welcome. What if I can't be here at 8 a.m.?
And don't worry about it. I mean, you just won't get the bonus points.
Okay. I'd be here. I have a child that the bus don't travel, so I'll have to take her unless I can come at a different time or something.
As long as you come between 8 and 9, can you make it between 8 and 9?
I should be able to.
Then there's no problem.
Okay,
Just
and if
take it when you get here.
Okay, and if I can't be here?
Then you can come to the Anderson campus if you want to, or let's just see if you can make it first, okay?
Okay, I'll message you.
If you can't make it, just email me or call me or whatever. All right.
Okay.
Wednesday, December 6th. That's my birthday. Everybody bring me a present. Let's see. After you have completed all the homework unit tests, you should check your grade box for your overall grade. The overall grade is what I use to assign you a grade for Tri-County Tech. So if you have a 67.9, then you're going to get a D for this class. Okay? That's what your overall grade is. If your overall grade is 98.3, then you have an A in this class. As simple as that. Okay? Make sure you truthfully complete evaluations on all your instructors. They should be going out. Have y'all got an email about your evaluations for your instructors?
Yes.
Okay, make sure you take care of that, and also visit Rate My Professors, because that's what a lot of students use, as well as y'all did. Of course, y'all didn't adhere to it. You went ahead and took, what's her name, 2.1?
Debbie 1.4.
Debbie 1.4.
Hey, Marshall. Hey, buddy. How are you? Doing all right. That's good to hear.
Are we through with the domestic family reunion? Okay, yeah. Can I be in control for a while? Okay. Make sure you take care of Debbie 1.2. Make sure you do an evaluation on her, as well as your Polycom classes. Okay, be truthful. All right? And when I mean be truthful is if you learned something, then make it known. If you didn't, then make it known. That's what I mean by be truthful. When just because you don't like somebody or just because your personality don't, check yourself and did you learn anything? Hopefully you did in here. I don't know about the other class, but I'm not even going to go there. Did you learn anything in Debbie 1.2's class?
Not one dang thing.
Okay, well you need to put that down.
I learned how to bullcrap a 7-page essay.
Okay, well you need to put that. You need to put that on Rate My Professor. All right, who's got questions about the last week? Also, let me ask you something. If I gave y'all a test and I gave you back your grades, I gave you back your test, and I graded, and I accidentally added 10 points to your grade, are you going to raise your hand and say, Hubert, you added the extra 10 points to my grade, you need to take it off?
Possibly.
Possibly? Really?
Someone needs to leave the classroom.
Yeah.
There's a 0% chance I'm going to say a word.
You don't look a gift horse what?
In the mouth.
In the mouth. If somebody gives you points, you do not write an email and say, Hubert, I saw something on MyLabs Plus and I really don't understand it. Really? You're really going to write me an email to say you don't understand something good happening? Okay? Now, if you've had me before, which none of you have, except for Miss Smith, I think has had me, I do something at the end of the semester, and you have to look for it. And if you look for it and you see it, then you say, all right, if you need it. And if you don't need it, then you don't get on the email and say, Humor, I noticed something on blah, blah, blah. I really do not understand this. Okay, please don't write me an email like that, because that'll just irritate the crap out of me, and it'll take you down to living in the ditch. It really will. It'll make the failure level go way up. All right? So please don't write me an email and say, I really don't understand what you're doing on MyLabs Plus. Okay? We got that?
Yes, sir.
Okay. All right. Who's got questions about the last week of class?
Not me.
Make sure I have those dates right. I think I do, except for the Wednesday. I screwed that up. But just make sure y'all come that morning so y'all can say what?
Hi.
That you took a what?
In class.
In class final.
Yes. All right. Now, next thing. Write that down. What was that? Okay, write that down. This is predominantly what's going to be happening the next week. Okay? We're going to be going over all of these things. I want you to make sure you write these down. I want you to make sure you learn them. If you haven't learned them, then something is wrong with the system. If you have learned them and forgotten them, then you need to review over them. All right, they're very similar because an exponential and a logarithm are very similar. A logarithm is a exponent on steroids, okay, pretty much. It has the same properties, except it's a little bit, it grows exponentially more than an exponent. It's used in business a lot because, guess what? It's in the first quadrant. You can't take the log of a negative number. So a lot of your first quadrant rules apply to logarithm. Okay. Oh, I forgot to ask y'all. Any good movies this weekend?
Nothing, man.
I haven't seen anything. I told y'all what. Huh?
I didn't see any.
Well, I tell you, the movies right now really suck. I mean, they're not.
It always sucks around right now.
Yeah, I know.
Yeah, and then usually like 4 or 5 really good ones come out.
Yeah.
They really want us to be depressed during
That's
the winter.
it. They want us to be depressed and bored.
Never. All the time.
The new Star Wars is coming out soon.
Yeah, I'm not a Star Wars buff. I'm more of a Star Trek buff.
I like
So-
both.
I like both, but I'm not going to stand in line for hours watching. I'm not going to do that. I don't stand in line for anything, pretty much. Former military people,
Just boot
veterans,
camp.
don't stand in line very much because that's all they do in the military is stand in line.
That's
All right.
true.
I'm the same color binder.
Hurry
All
up and
right, y'all
wait.
got it all written down yet?
Nope.
Oh, stuff.
We got a picture of it if you want to just continue.
Yeah, picture is great. You need to write it down in your notebook. Give y'all a few more minutes. Oh, also, there still are openings in the Anderson and the Easley campus for this class, for this Polycom of 130 next semester. So
I
if
got
you still want to do that, add it, okay?
Gotcha.
I don't foresee any problems with that. The Pendleton campus, I think, is still full. Although my department head said that as soon as they find out it's a poly class, they'll all drop out. Well, I emailed the class, and none of them have dropped out. So
They probably don't know what that means because I sure didn't when I
Yeah,
first
I didn't
started.
either.
I
They
walked in
probably
here and was
don't
like,
what?
where's the teacher? And then you started calling me, and I was like, oh, God. I was like, what?
What's happening?
Well, I see on the screen and not in front of me, but
oh well. I hope that y'all will
It
follow
turned out
me
well.
along with the calculus because it kind of helps
Marshall's
to have
gonna
the
help
same teacher. Huh?
Marshall's going to help me sign up for this class.
Okay,
Online.
good. Make sure
Thanks,
you
Marshall.
get
No
on.
problem, buddy.
Okay.
There-
Are y'all through?
Yes,
Okay.
sir.
Y'all through? Okay. Remember, I don't want communication between y'all, okay? I want y'all to stay stagnant from each other. All right. Exponential rules. The product rule. What is the product rule? If you have the bases the same, and you're multiplying, what do you do to the exponents?
Add them.
Add them. All right? So I'm going to go to my handy dandy. Hold on a second. My handy dandy dojigger here. And I'm just going to make this bigger, and we're going to cancel that. Make sure you get your highlighters out if you got some, because you need to make some distinctions here, because people always get kind of confused with all these rules, and they kind of overlap, and people just get confused. So, is that as far as that? There we go. All right, I'm just going to cover a lot of it here, and a lot of this should be reviewed to you. Hopefully, if you're in this class, you've had Algebra 1, Algebra 2, or comparable classes since, high school. The chances are this is a review for you. Let's go with x to the fourth times x to the third. Well, the bases are the same, so you would take your highlighter and you would highlight these guys right here. All right? That's what I mean by the bases are the same. The bases are the same. You get x to the 4 plus 3, which is x to the 7th. You can also have 2x to the 2nd times 3x to the 4th. Again, the bases are the same. What students do is they look at this as the base, but that's not the base. That's a coefficient. This is a base. All right? This is the base. This is the base. You go with the base, not the coefficient. So that's going to be 2 times 3 is 6. The base is x, and that'd be 2 plus 4, and that's x to the 6th power. So the only thing I want to really bring across and hash out is that you need to know what the base is. If you don't know what the base is, then you're going to be confused with the product rule and the quotient rule. Now, the quotient rule is the inverse operation of the product rule. So if the product rule is adding, I'm sorry, I just don't understand wearing your pants down around your knees. I just don't understand that. Will somebody explain that to me one day before I?
Where did that come from?
Well, I just saw somebody written outside. I think it comes from jail. I think it means you're available for something about the shower or something.
I've heard that also.
If you have the quotient rule, that's x to the 4th divided by x to the 3rd, then instead of adding exponents, what do? Subtract. You subtract. You got to make sure you have the same base. Now what happens with this? Did y'all hear that?
Yeah, it is.
Okay. Somebody needs to turn their microphone down. I meant their speakers down or something. All right. There's your base. So you do have the same bases, and that'll be x to the 4th minus 3 is equal to x to the 1st, or x. Now what happens, this is what happens to confuse people with this. X to the 4th divided by y to the 3rd. And students kind of blow a fuse on this because they go, well, you can't do it. Why can't you do it? The bases are not what? The bases are not the same. And it's very important that you understand most of these properties are based on similar bases. Okay? Bases are not equal. Okay, so you can't even do anything. All you can do here is rewrite it. X to the 4th over y to the 3rd. That's all you can do. So you need to understand that. If I give you 4x to the fourth over 3x to the second, then your answer is 4/3. Then write x to the 4 minus 2. Oops. And that's 4/3 x to the what? Second. Now you can rewrite that as 4x to the second over 3. You can do that. Either one of those is the answer. But it's kind of like I tell my Math 120 class. In Math 120, the math is not that difficult, but you have to be aware of the question. You have to read the question. You have to retain what the question is asking. Okay? Here, is the math difficult? No. But you have to be aware of, one, you have to be aware of the base. And two, you have to be aware of which property. Okay, because the math is not that hard. All right, now here's two examples that really get people. X to the third, y to the negative second, x to the negative sixth, y to the fourth. Now, the reason I'm making sure you understand the exponential rules, is because if you don't understand the exponential rules, then guess what? You're going to suck at the logarithmic rules. Okay? If you suck at the exponential rules, you're really going to suck with the logarithmic rules. Okay? So it's kind of like building, if you're a bricklayer, laying brick on a sandbox. Okay? If you lay brick in a sandbox, guess what? Those bricks are going to fall. And if you try to learn the logarithmic rules and you don't know how to do the exponential rules, then you might as well just not even do the test. Okay? So the bases are the same. The x is the same. Now this is what I tell students to do when they really suck at exponentials. I tell them to break it up. And the same thing with this is supposed to be green and yellow, but it's not. I guess I need to get a better yellow. Anyway, and break it up like this. X to the third times x to the negative sixth times y to the negative 2 times y to the fourth. Now how can I do that? What law in mathematics lets me do this? Starts with a C. O. M. M. U. T.
Union.
Commutative law. 2 times 3 is the same as 3 times what? 2. So that right there lets me maneuver them around however I want to. Here we get x to the 3 plus a negative 6 times y to the negative 2 plus 4. X to the 3 minus 6, y to the negative 2 plus 4. What's 3 minus 6? Negative 3, Hubert. Thank you, class. And y to the second. And that's your answer. Now, at this point, somebody might say, well, we don't want a negative exponent, but we haven't learned the inverse rule yet, so we're going to just stay with this right now. And we'll switch it when we get to the inverse rule. Here's another example that people cringe on, and this is like, these are both, these right here I'm showing you are basic standardized test questions. Here's one that you'll see on a standardized test. 6x to the fourth, y to the sixth, w to the third, over 3, x to the negative 2, y to the fourth, w to the fifth. Break it up. 6 divided by 3, x to the fourth divided by x to the negative 2, y to the sixth divided by y to the fourth, W to the third divided by W to the fifth. 2, X to the 4 minus a negative 2. Y to the 6 minus 4. W to the 3 minus 5. And 2x, what's 4 plus 2? 6. 6 minus 4 is 2. And 3 minus 5 is negative 2. So that's how you use the product and the quotient rule. Now, do put a star here, and I'm not going to go any further here, but here you could use the inverse rule to finish it, but we haven't covered it yet, so I'm not going to muddy the waters by doing another rule we haven't done yet, reviewed yet, in the middle of this one. So that's your answer to this point. Now, let's talk about the power rule. Most used. The power rule says a to the n raised to the m power is equal to a to the n times m, or something similar to that. Meaning that if you have a exponent raised to another exponent, what do you do to the exponents? You multiply them. So that's a to the n times m. All right? Now, this is best used as kind of like the what? It's kind of used like the distributive law. What does the distributive law do in algebra that helps you solve the equation? Two times x minus 3 is equal to 4. What does the distributive law do right there to help us solve the equation? Yes, you do multiply using the distributive law, but what does it do? That's not rhetorical. I want y'all to interact with me, please. Don't say you don't know, because you do know.
It gets rid of the 2.
It gets rid of the what?
The 2.
No. It distributes the 2.
Well, yeah, but
it gets rid of the what?
Parentheses.
Parentheses. Gets rid of parentheses. What does the power rule do to this right here? It gets rid of the parentheses. So use the power rule kind of like the distributive rule, distributive law. Whenever you want to get rid of the parentheses, you use the power rule. So 4x to the 4th to the 2nd power is equal to x to the what? 8. Now, where do they get you on these? This is where they get you. 2x to the 4th raised to the 3rd power. And why do they get you on this one? Because that 2 is raised to a what power? To the 1st power. So you have to multiply this 3 not only by the 4, but you have to multiply it by the what? 1. And that's where they get you on a standardized test. So that's going to be 2 to the 3rd power times x to the 12th power. And what's 2 to the 3rd power? 8, Hubert. That's right, class. So this is where they're going to get you on a standardized test. They'll just put a 2 there, and they just assume that that 3 goes with that 1. Now, of course, if I could write 2 to the 4th power, well, if I gave you 2 to the 4th power times x to the 3rd power raised to the 2nd power, you would say, well, why are you writing 2 to the 4th as 2 to the 4th? Well, that's usually why you don't see this. All right? Usually you see it to the 1st power. You don't see this. Because 2 to the 4th power is what? 16? Usually you'd see this. Well, you wouldn't see this, because then it'd be, you wouldn't see it. Okay? Now, you can also distribute a negative. 2x to the third power multiplied or raised to the negative third power. Now, we haven't got into the inverse power rule or the inverse rule yet, so if you wanted to distribute, which that's like whips and chains, if you like that kind of stuff, it's just more pain. So that would be 2 to the negative third, x to the negative ninth, which is really lovely, but you can distribute a negative also. All right, so that is the power rule. The power rule is the distributive law for exponents. And you'll see that again with logarithms. And this is kind of a review, so that's why we're going a little bit fast. The inverse rule. The inverse rule and the inverse power rule, and you won't see this in the book, but I think they are used basically for aesthetics. What's aesthetics? SAT word for the day. What's aesthetics?
To look pretty.
To look pretty. Whoever said that, you're right. That's what it is. To make something look more presentable, okay, or look pretty, all right, or how something looks. So the inverse rule basically gets rid of the negative what? Exponent. All right. The inverse power rule, inverse power rule. The inverse power rule makes things easier as far as a negative exponent. All right. So, do you have to use these? No, you do not have to use them. But a lot of people use them because, well, let me give you an example. In American culture, you do not want a negative in the what? Exponent. But I remember at Clemson, when I was at Clemson, they had an Asian teacher there, and the Asian teacher, she didn't care if you had a negative exponent or not. And we asked her, said, yeah, we're supposed to get rid of that negative. She said, in China or wherever she was from, they don't worry about the negative exponent. They just leave it where it is. So it's not, can you be marked wrong mathematically? No. You cannot be marked wrong mathematically, but if the directions say in simplest terms or in all positive terms, then they got you. All right, but mathematically, there's nothing wrong with it. Okay? So here it is. If I have 1 over x to the negative n, then I can flip it and get x to the positive n over 1. And if I have x to the negative n over 1, I can flip it and it becomes 1 over x. So all you have to remember with the inverse rule is flip it. If you have a negative exponent, flip it. But what happens is they are so discombobulated into one problem that the students can't break it up. If you break up these problems, it'll make things a whole lot easier. What I mean? Well, let's say they give you one like this. 3x to the negative 2, y to the 4th over 3x to the negative 4th, y to the 6th. All right? Break it up. 3 over 3. X to the negative 2 over x to the negative 4. Y to the 4th over y to the 6th. And now work with each one. Of course, that's 1. Now this, I can bring this upstairs and I can bring this what? Downstairs, and that'll give me x to the 4th over what?
X to the 2nd.
And then I can bring this up. I don't want to mess with this because if I bring this upstairs, it's going to be a negative. So I don't want whips and chains here, so I'm just going to leave this alone. So this comes out to be 1. And then this is x to the 4th over x to the 2nd, which is x to the 2nd. And then this is y to the what? Negative 2. And then what do I do with that y to the negative 2? I flip it, and then that becomes x squared over what? X squared over y squared. So again, this is something that just makes things look pretty. Is there any mathematical distinction between x, y, negative 2 and x squared over y squared? Is those two things equal to each other? Yes.
Yes.
So mathematically, it's not incorrect. Okay? Now, the inverse power rule. The inverse power rule says if you have x to the n over y to the m raised to the negative w power, then all you need to do is flip what's inside and makes that positive. So y to the m over x to the n raised to the positive w power. And that's all you do there. And why would you do that? To work with a positive instead of a what?
Negative.
That's all. That's the only reason. So this is to work with a preferred positive number. That's why you'd use it. Now, let me ask you this. On these questions, on these five rules that I've given you, 5 exponential rules, is there an order for you to work problems, or use any of them in any place and come out with the same answer? You got a 50 shot.
Order.
No order. There is no order. Okay? You can use the inverse rule first and use the product rule after the inverse rule, or you can use the quotient rule before you use the inverse rule. What do you mean, Hubert? Well, let's give you this one. X to the negative third over x to the fourth, or negative 4. All right, what laws can we use here?
Inverse.
I can use the inverse law, or I could use the what? The quotient rule. Does it matter which one you use? No. If I use the inverse rule, I bring this up, I bring this down, I get x to the fourth over x to the third, and now I use the what? I use the product rule and get x to the 4 minus 3, which is equal to what? X to the first. But if I use the product rule first, or quotient rule first, I get x to the negative 3 minus what? Negative 4. And that's equal to x to the negative 3 plus 4, which is equal to what? So does it matter which way I do it? No, it does not. So here's another example. If I have x to the fourth over y to the third raised to the negative 5th power. All right, what could I do first on this one?
Inverse power rule.
I could use the inverse power rule, but I could also use what? Power rule, Hubert. Yes, you can use the power rule and then use the inverse rule. So here I'm going to use the inverse power rule. Inverse power rule gives me y to the third over x to the fourth raised to the 5th power, and then use the power rule, and that gives us y to the 15th over what? x to the 20th. Now down here, I'm going to use the power rule. X to the negative 20th over y to the what? Negative 15th. And then use the inverse rule. Bring that upstairs, y to the 15th over x to the 20th.
Literally doesn't matter at all.
Really doesn't matter as long as you're doing the correct law. It doesn't matter as long as you're not making up something. Doesn't matter which order you do it in. All right, one more thing I want to show you on the basic review of exponents is the radical exponent. If you have the square root of x to the first power, that's equal to x to the 1/2 power. Now this is essential in calculus. All right, when you start learning rates of change and taking the derivative of a function, there is no such thing as a radical in calculus. Radicals and calculus do not mix. Anytime you see a radical in calculus, the first thing you do is change it to an exponential function. So if I have x squared, take the 5th root of x squared, that's equal to x to the what? 2/5. So this is exponent over what? Index. Exponent over index. Your exponent is right there. Your index is always where? In front of the what? In front of the radical, Hubert. That's right, class. This has been a great class, but y'all have two weaknesses. Well, sometimes you have two weaknesses. One, y'all don't talk, which sucks, okay? Makes the class long and drawn out, makes it boring, and sometimes y'all have a rudeness factor that goes up a little bit, but not too much. But other than that, I just evaluated y'all. So I figure I'd evaluate y'all. Since y'all evaluate me, I'll evaluate y'all. But other than that, y'all a great class.
I just don't want to sound stupid.
What?
I just don't want to sound stupid.
Oh, okay. You're not going to sound stupid. I would rather you interact than not interact, but I told y'all that at the beginning of the semester, and y'all kind of like gaffed me off and said, bump him. So
Well, every teacher says that.
what?
Every teacher says that. And then you say something stupid, and then they kind of write you off.
No, I don't usually say you're stupid. I just say that you're a loser and you're probably going to fail the class. That's all I say. But I don't say you're stupid. All right, so exponent over index. So if I give you the 4th root of x to the n power, what is that? X to the n over what?
Over 4.
4, or x to the 1/4 n power. Either one of those. You need to learn how to rewrite. When you're in calculus 1, 2, or 3, whether you're in engineering calculus, what was that? Or in business calculus, these don't exist anymore. When you see, the first thing you do when you see these things is you change them into a radical exponent or an exponential function, whichever one you want to call it. Okay? Now, your homework on whatever section this is, 5.1, will be a lot of review questions over the basics. So make sure you do the homework before we come back, because I don't want to go into logarithms until you understand. So I'll probably put a time limit on this homework, not because it's the end of the semester, not because of that, because you need to do it before we move on to logarithms. All right, so I'll probably put a couple of day limit on it, so some of you deadheads, won't put it off. Okay. Questions? Great. Complaints?
No.
Okay. Does anybody have any questions about the last week of class? All right. So if you see something funny come up on My Labs Plus, what are you gonna do? You're gonna go with it, right?
Email you immediately.
Yeah. Email me 15 times, going, I don't understand. Just go with it. Go with the flow, okay? Everybody understand? All right. Y'all have a good day, and I'll see y'all tomorrow, which will be what, Wednesday? All right. See y'all.
Tomorrow, Wednesday.
Yeah, tomorrow is Wednesday.